Here's another problem where I might be tempted to use u sub. We have the integral from 1 to 4 of x minus 1 times x plus 2. It looks like a product rule for derivatives, but if I go to use u sub to take the antiderivative, it's tough to tell which one to choose for u because neither of them are raised to a power. It's not like one of them is raised to the 7th or something. So if I just make u the first factor, for instance, the derivative of x minus 1 would just be 1. Derivative of 1x is 1. Derivative of negative 1 is 0. So then we would say du dx and multiply by dx. And when we go to use u sub, we would say, hey, this is u. I have the dx that I need for my du, but it should only have a 1 in there, and it has an x plus 2. So this has an extra x. So still it's off by an x term, which implies it's not u sub. So whether you have an x that you don't need or you're missing an x that you do need for your du, if it's off by an x term, it is just not a u sub problem, which tells me that I need to use some algebra to try to get this simplified. So I'm going to do some other side work here, not u sub, but just some multiplication. I have x minus 1 times x plus 2. I can FOIL that. X times x is x squared. X times 2 is going to give us 2x. Negative 1 times x is going to give us negative 1x. And then negative 1 times 2 is going to give us negative 2. So I end up with x squared. 2 minus 1x is going to be an x minus 2. And that's what we can rewrite that integrand to be. So we have the integral from 1 to 4 of x squared plus x minus 2 dx. And now that I've done all that work, I'm finally ready to actually take the antiderivative of it, which means I'm going to add 1 to the powers. So 2 plus 1 is going to give me 3, so 1 over 3x to the 3 for that first term. The next term is just an x, so that power on that is 1. So I'll have 1 plus 1 is 2, x to the 2. So antiderivative of 1x is 1/2 x squared. And then lastly, antiderivative of negative 2 is negative 2x, normally plus c, but here we have bound, so I'm going to do an evaluation bar. Each time in my mind, I'm contemplating, do I write a plus c or do I do an evaluation bar? And I look at the original integral to tell me which one to do. And now fundamental theorem of calculus says plug in your upper bound to the entire antiderivative. So 1/3 of 4 cubed plus 1/2 of 4 squared minus 2 times 4. There's my upper bound. I plug in just that number into my calculator and see what I get. And I'm getting 21.3, repeating for that. And then I have minus, I'm going to plug in my lower bound to the antiderivative. So 1/3 of 1 cubed plus 1/2 of 1 squared minus 2 times 1. And I'm going to get minus a negative 1.16 with the 6 repeating. So fundamental theorem says plug in your upper bound minus your lower bound. It just ends up that we're minusing a negative, which means we're really going to add it. So the net area under this curve is 22.46 with the 6 repeating.